Sir, good evening. Sir, வணக்கம். இருக்கீங்களா? சார் வணக்கம் சார். லைன்ல இருக்கீங்களா யாராச்சும்? சார் வணக்கம். சார் வணக்கம், கேக்குதா? சார் குட் ஈவினிங் டு ஆல். கேக்குதா சார்? கொஞ்சம் பதில் சொல்லுங்க ப்ளீஸ். சார் வணக்கம், கேக்குதா சார்?
சார் கேக்குதுங்க சார்.
சார் ஸ்டார்ட் பண்ணலாமா? Start now, sir. Can you start now? Sir, we'll start now, sir. Sir, கேக்குதான் மட்டும் சொல்லுங்க. அதுக்கு பதில் சொல்லுங்க, please.
கேக்குது சார், பேசுங்க சார்.
ஓகே ஓகே, யாராவது பதில் சொல்லுங்க, நான் ஸ்டார்ட் பண்ணிருப்பேன் மேடம். யாருமே பேசவே மாட்டீங்க. வாய்ஸ் கேக்குதா இல்லையான்னு எனக்கு தெரியல. ஓகே ரைட். ஓகே சார். 8th chapter electrical utilities, 8th chapter lighting system. இதுல வந்து நம்ம வந்து வேரியஸ் டைப்ஸ் ஆஃப் லைட்டிங்ஸ் வந்து பார்ப்போம். இதுல என்னன்னா, this chapter வந்து contains most of the outdated lamps. Actually, those lamps were still in service 10 years back, but now everything has been replaced by LED lamps. This chapter requires us to design a lighting system, either by replacing the existing system or by providing new one. So இதுல ஒரு 10 மார்க்கு மேல வரும். 4th சாப்டர்ல, சாரி 4th சப்ஜெக்ட்லயும் இந்த கொஸ்டின் கேட்டாங்கன்னா 10 மார்க்கு கண்டிப்பாக வரும். கண்டிப்பா வரும்னு சொல்ல முடியாது, பட் தேர்ட் சப்ஜெக்ட்ல கண்டிப்பா 10 மார்க் கண்டிப்பா வரும். இல்லைன்னா லைட் சோர்சஸ் அண்ட் டைப்ஸ் ஆஃப் லேம்ப் வில் சி. கொஞ்சம் ட்ரையா தான் இருக்கும். அப்புறம் டெர்மினாலஜிஸ், illuminance, method of calculating illuminance, energy efficient lighting controls. இது energy efficient lighting controls இதெல்லாம் வந்து நம்ம இன்னைக்கு பார்க்க போறது இல்ல. இது வந்து 11th day. Method of calculating illuminance கூட நம்ம வந்து பார்க்க போறது இல்ல. The basic out of all electromagnetic radiations, the narrow band between 400 to 700 nanometers corresponds to visible light. It's a narrow band. Beyond that and before that, we cannot see the electromagnetic radiation, only we can feel. This 400 to 700 nanometers of wavelength visible light is capable of simulating our retina. That's why we are able to see it. That too, greenish yellow is very much visible. Just remember these values are 400 to 700 nanometers. Human eye response. Lumen. That's the first definition we'll be seeing today. Lumen, that is not one sir, LM. LM is the photometric equivalent of what weighted to match the eye response of the standard observer. Standard observer means we usually say standard person means 70 kg person. We call him as a standard person. Just like that, standard observer is taken as a reference. Yellowish green light receives the greatest weight because simulates eye more than blue or red light of equal radiometric power. 1 watt is equal to 683 lumens at 555 nanometers of wavelength. We saw that between 400 and 700 of wavelength in nanometers, the light is visible. Three primary conditions to ensure energy efficiency in lighting system. We are going to lighting systems now. Selection of the most efficient light source possible in order to minimize electricity consumption and cost. This is the first requirement. And this alone will not be sufficient. We'll be seeing two more points also. Matching the most efficient lamp type to the intended work. Intended work means for any task, we are not going to choose one and only energy efficient lamps. We'll be choosing many other lamps because each and every type of lamp has got its own advantage. For example, you can see in the traditional mute பண்ணுங்க சார் மொத்தம். சார் மொத்தம் கொஞ்சம் மியூட் பண்ணிக்கோங்க ப்ளீஸ். The second point is matching the most efficient lamp type to the intended work task or aesthetic application. In the traditional silk sarees section, we'll be seeing the incandescent lamps, 200 watts incandescent lamp. We will be seeing in the old traditional silk saree showroom. Because the color rendering index means the actual color will be visible under incandescent lamp, whereas in other lamps the actual colors will be seen as a modified color. Supposing we may choose a violet color thinking that it is black, but it may turn out to be a violet one in the daytime. These are all the practical difficulties we face in the lighting system. Whereas in incandescent lamp, this problem doesn't arise because the color rendering index for incandescent lamp is very high. The third one is establishing adequate light levels. Adequate light levels are essential. Supposing we have a lawn, and in that lawn, it may require many fittings, but during night time, we may not find any usage there. But it may interfere with the security and safety. Safety means industrial safety. Any accident may happen. It may hamper the security system. So So all these things require adequate lighting level. So we cannot compromise that compromise that lighting efficacy there. So we need to consider three points. One is energy efficient, second one is cost light, third one is adequate light levels. So keep all these 3 points in mind, sir.
Yes.
So you got the 3 points of okay. Now, luminous flux. What's that luminous flux? Luminous flux describes the quantity of light emitted by a light source. It's a measure of lamp's economic efficiency. Flux, luminous flux means light, that's all. Measurement of luminous flux is lumen. The lumen rating of a lamp is a measure of the total light output of the lamp. Light sources are labeled with an output rating in lumens. This is the basic units are lumen. We'll be seeing lumen. See in this case, 25 watts bulb gives 230 to 270 lumens. 40 watts gives 440 to 460, whereas 60 watts bulb gives 800 to 850 lumens. So lumens increase with the power of the bulb. Lumens means lighting, more lighting means more brightness means more power. Lumen is the measurement of luminous flux. Don't forget lumen. The other one is illuminance. Lumen is different from illuminance. Illuminance is the quotient of the luminous flux incident on an element of the surface. Suppose we are designing one showroom, for example, a jewelry shop. The level that we will be seeing the jewelry will be up to our hip level. In that particular level, what is the luminous flux? What is the illuminance we require? So we will be calculating the illuminance at that particular area. That is, see that point, surface at a point of surface containing the point by the area of that element. Lux is the metric unit of measure of illuminance of a surface. 1 lux is equivalent to 1 lumen per square meter. Lumen is total, lux is lumen per square meter. That we call as illuminance. Illuminance decreases by the square of the distance. Inverse square law. I just want to explain one basic concept which will not be available in our textbook, sir. If you want, I can show that. Can we see it, sir? One basic point. Okay. Inverse square law means the intensity of light per unit area is inversely proportional to the square of the distance from that source. Do you agree, sir? The intensity of light per unit area is inversely proportional to the square of the distance. when we move towards sun or move away from sun, the same thing applies. The intensity of light per unit area is inversely proportional to the square of the distance between the observation point and the source. Yes, E is equal to I by D square. See, let us imagine a sphere, so big sphere, and S is the source, point source. It is emitting light towards all directions. So, at this particular point on the surface of an imaginary sphere, at that particular point, what will be the illuminance? The illuminance will be intensity at the surface of sphere is equal to the points or source strength S divided by the sphere area, surface area of the sphere, that is 4 pi r square, S by 4 pi r square. So at this particular point, this is the source, this is the point 1, this is point 1. If the distance is r, then the intensity here will be S by 4 pi r square. If the distance is to r, what will be the intensity then? It will become 1 by 4. For 3, it will become 1 by 9. We get the idea, sir? So, intensity of light per unit area is inversely proportional to the square of the distance from the source. We can write it like this: E1 D1 square is equal to E2 D2 square. Yes, sir, we'll do one problem, sir. The illuminance is 10 lumen per meter square from a lamp of 1 meter, a lamp at 1 meter difference. What would be the illuminance at half the distance? Lamp is at a particular point. Illuminance is 10 lumens per meter square at 1 meter distance. What will be the illuminance at the half distance? See, E1 is equal to 10 lumens, that is 10 into that distance is 1 square, is equal to E2 into 0.5 d square of the distance. So we can find E2. It will be 40 lumens per meter square. So what we observe from here is at 0.5 meters from the lamp, the illuminance is 40 lumens per meter square. It moves just 0.5 meters from that place. Earlier it was at 0.5 meters. Now it is at 1 meter. The illuminance gets reduced to what? Just 10 lumens per meter square. Before that it was 40, now it is 10. You see the difference. So E1 D1 square is equal to E2 D2 square. This formula we have to keep in mind to do the problems. Average maintained illuminance. Is the average of illuminance measured at various points in a different. Suppose we design a showroom and we maintain we calculate the illuminance at various levels and we get one average value that is called average maintained illuminance. Circuit watts is the total power drawn by the lamps and ballasts. For example, if a tube light consumes some 40 watts, the 40 watts is the total power drawn by the tube light, but it is not for the light alone, because the power drawn is inclusive of the choke, or we call it as, technically it is known as ballast. So it includes ballast and the light energy. So the total circuit watts is known as the total power drawn by the lamps and ballast in a lighting circuit under assessment. Circuit watts. All these words we need to keep in mind. Luminous efficacy. It is the ratio of luminous flux emitted by a lamp to the power consumed by the lamp. That's all. Lumens per watt. It's an important terms are luminous efficacy is lumens per watt. We'll be comparing this term with other lamps, with many lamps like sodium vapor lamp, incandescent lamp, LED, and so on. We'll be seeing that what is the luminous efficacy of that particular type of lamp. Okay.
Sir, circuit what is total, sir?
Yes, sir. Yes, sir. It is what total. Circuit watts is total, sir. Total power. Lamp circuit efficacy is the amount of light lumens emitted by lamp. This is amount of light emitted by a lamp for each watt of power consumed by the lamp. That is including control gate losses. All these terms will be slightly confusing, sir. We have to read it again and again, but some terms will be very much of importance. For example, luminous efficacy, circuit watts. These two are very important terms. Installed load efficacy. It is the average maintained illuminance provided on a horizontal working plane per circuit watts. That's per watt per square meter. Installed load efficacy. Installed power density. What is the difference of power needed per square meter of floor area to achieve 100 lux? This will be particular application specific for a jewelry showroom or a workshop or something. We'll be calculating this installed power density. And these terms will be confusing, sir. CRI. CRI is an important term, sir. Color rendering index. CRI is a measure of the effect of light on the perceived color of objects. Already I told you, the silk saree sections will be having incandescent lamp because the CRI of incandescent lamp is excellent among all the categories of lamps. To determine the CRI of your lamp, the color appearances of a set of standard color chips are measured with special equipment under a reference light source with the same color, correlated color temperature as the lamp being evaluated. Just for sake of knowledge, I have given this, sir. If the lamp renders the color of the chips identical to the reference light source, then the lamp's CRI is 10. Luminaire is the device that distributes, filters, or transforms. It is an assembly, sir, assembly of lamps. The luminaire includes all parts except the lamps. We generally call it as the luminaire as fitting, like fitting and all. Ballast. Ballast is a current limiting device to counter negative resistance. What is the negative resistance coefficient, sir? All the resistances will be having positive resistance coefficient. Do you agree, sir? All the resistance. For an example, incandescent lamp. We'll discuss one point here. For an incandescent lamp, that's our tungsten filament lamp. Have anyone measured the resistance across the filaments, sir? I measured and found to be 0, sir. Multimeter shows a dead short value. Let us calculate in the main calculation, sir. For example, 100 for 100 watts. What will be the current for that particular lamp, sir? What will be the current? 100 watts. Watts divided by voltage will give the current, right? 100 divided by 250. What is the current, sir? 0.4. Am I right? What's that? For an 100 watts light, the current will be around 0.4 amps. Do you agree or not?
Fine.
Yes, sir. Am I right, sir? Sir, please correct me if I go wrong. Hundred is what, sir? That is VI. VI divided by V will give us current. 100 divided by 250. I am taking the voltage as 250 instead of 230. Okay, sir. For calculation purposes only, I took 2.
Okay.
Let us calculate the resistance, sir. What will be the resistance now? Resistance will be same thing, I square R, otherwise
Voltage by current. Voltage
yes,
by
sir.
current.
Yes, sir, exactly, sir. That is 250 divided by 0.4. It will be around 60. Okay, sir. Not 60, 600. Am I right? 250.
Yes, sir.
Yes. Sir. So, an 100 watts bulb will have a resistance of 600 volts. But when I saw the continuity tester was showing dead short. Why, sir? Because the resistance at room temperature will be very low, but the resistance will rise when the tungsten gets heated up. When the temperature rises, the resistance will also increase. This is positive resistance coefficient. Positive resistance characteristics. Okay, sir.
Correct.
I just wanted to, it doesn't have any connection with this chapter, but I just wanted to clarify this negative resistance characteristics. You see the second lines are negative resistance characteristics. What is that negative resistance characteristics? For any discharge lamp, as the temperature goes up, the resistance will come down. So more current will. So it is opposite to a incandescent lamp. That's what I wanted to share with you.
Okay. Okay.
Yes, sir. In case of a fluorescent lamp, it aids the initial voltage built up required for starting. In an electric circuit, the ballast act as a stabilizer. Yes, sir. That's all. Igniters are used for starting high-intensity discharge lamps, such as metal halide, sodium vapor lamps, etc. Igniters are required. These lamps are all already outmoded, sir. Let's see. Lamp types, there are 3 major categories. First one is incandescent, second one is fluorescent, third one is high intensity discharge. What is incandescence, sir? What is incandescence? Anyone?
Our ordinary tension lamp.
Yes, sir. I am asking what is the principal property of incandescence? What is incandescence? Incandescent lamp, I am not asking. Incandescence, what is incandescence?
As the current
Ah,
goes in, the
yes, sir.
tungsten will be heated up, and then thereby the light is emitting. That is the
Yes.
incandescent lamp.
Yes, sir. Incandescence is the principle of
Oh,
emitting light
okay.
beyond a particular temperature. It is not the red hot that is giving out the light. It is not the red hot, sir. It is incandescence. The principle is incandescence. We have seen Petromax light and all. What we are doing, we are heating up the element. When it reaches a particular temperature, it will glow out and it will give out light.
Light.
Yes, that is that particular property is known as incandescence, like
Oh.
Petromax light. The same thing happens in the tungsten filament. It goes beyond, when it goes beyond particular temperature, it gives out light.
Okay. Okay.
Yes, sir.
Understood.
Oh, yes, thank you. Known as GLS lamp. What is GLS? We may be asked for one more question, sir. GLS. GLS means General Lighting Service Lamp. It's a word term. It includes filament, bulb, fill gas, or vacuum, and cap. The gas, inert gas, and vacuum is kept inside the bulb to keep the tungsten filament from burning out. In the presence of oxygen, the tungsten filament will burn out. I saw it when I was around 18 or 19 years. The bulb got broken and the filament was intact. I tried to see what will happen if I
Give the
connect.
supply.
Yes. At that instant, it glow like normal lamp only, but within not even seconds, sir. Within
Tungsten
seconds,
breaks.
yes.
Tungsten
Fraction of
breaks.
seconds, yes, fraction of seconds, got smoke and burn out.
Filament becomes
Yes, just like an ash. In presence of oxygen, it will burn out. That's why they fill it with an inert gas or vacuum. Incandescence is the emission of electromagnetic radiation, including visible light, from a hot body as a result of its high temperature. Petromax slightly is a server.
beautiful, sir. Beautiful.
Hmm.
Nicely explained.
இது எப்படி பார்க்கலாம்னா, if we connect two lamps in series, for example, our 200 watts bulbs or 240 watts, whatever it may be, two equal watts bulb in series. அப்ப என்ன ஒன்று கேட்டீங்கன்னா, the voltage share will be off. That means
50.
instead of 250, will be giving instead of 240, will be giving 120, 120.
120 each.
At that particular voltage, the I square R will be very less, so it will not emit that much of light energy. You
Okay.
will see some red dot in the filament, but it will not give out much.
Sometimes off light also.
Yes, yes.
Off the light.
Yes, it will be very much, very less, sir. Okay.
Madam, please. Great, Geeta ma'am.
Sir,
Please unmute your video, ma'am. Please. Disturbing. Video, audio, please. Geeta ma'am. Okay, fine. Thank you.
sorry, sir.
No mention, ma'am. No mention.
Sir, incandescence. Inside this will be argon, krypton, and nitrogen, sir. Any one gas will be inside this bulb. There's gas bulb.
Anyone?
Yes, sir. Yes. Tungsten filament
But is it marked there? Any there? Normally, I think argon is there. Krypton and nitrogen also there.
I don't know practically what they are using in
Argon is
commercially.
practical. Commercial.
Yes.
In the olden days, we used to have argon only. But these two, okay, fine. Only one at a time will be there.
Yes, sir. Nitrogen will not assist burning. That's sure. This one is tungsten filament, support wires, lead wires, and Dumut wire. What is it, Dumut wire? Dumut wire is nothing but the wire which is leading into the bulb. There is a possibility of leakage of gas from this point, right, sir? Because so that's why they are using that Dumut wire. Dumut wire is nothing but a nickel iron alloy. The expansion, thermal expansion is same for Dumut wire for glass also. So it perfectly hermetically sealed. That word hermetically sealed. Dumut wire is used for sealing the bulb. Hermetically seal the bulb. Exhaust tube, stem, fuse, cap. Okay. We saw when discussing the.
Please, participants, please mute your audio, please. Yes, sir. Proceed, sir.
Sir,
tell me, sir.
We discussed in while discussing the chapter 1, sir, right?
Okay.
In incandescence lab, the energy goes. This is Sankey diagram, sir. The energy input 70% goes as infrared radiation, 20% lost by conduction and convection. Only 10% visible light is we are getting. So it is nothing but a 90 watts, 100 watts bulb is 90 watts heater only.
Okay. Where it 70% IR infrared radiation goes, sir?
Yes, sir. It will go out as radiation, but when we are using it in an enclosed chamber,
okay,
this will strike the enclosed body or something. We are usually we cover it with papers and cloth inside a motor, sir. So it will be reflected back and converted as into heat only.
We are telling about the incandescent lamp, no? This is for incandescent lamp.
Only for
Sankey diagram for incandescent lamp, correct?
Yes, sir. Yes, sir. Yes, sir.
We are giving 100% input, electrical input. Only 10% is visible as a radiation, light radiation. Light is visible. 20% lost by conduction and by convection. That is okay.
Direct heat, sir.
Direct heat, okay.
Infrared is also.
Infrared is also radiation.
Yes,
it's also radiation. Where it actually eliminates, sir, this radiation you can see?
It will go out, sir.
Oh, along with the light.
Yes, it will go to infinity.
Then it is harmful to user, you know. Infrared radiation is harmful.
No, sir. No, UV is the harmful radiation, sir. Infrared is not so, because we are also emitting infrared.
Okay. Do not harmful. Okay. For eating purpose and all, for therapy, people, doctors used to.
I don't say it is not harmful, but UV is harmful.
Ultraviolet is harmful. That is right. But we cannot.
Because everywhere we can see infrared radiation around us. Every human body, every animal is emitting infrared. In that principle only, that sensors are available, infrared sensor.
Okay, that's right.
Reflector lamp, it's also a incandescent lamp. Only thing difference is the half of that inner surface will be coated with a reflector material. That's all, to increase the output to a particular location or task. Okay, sir. That's all. Halogen lamp. Halogen lamp. It's also an incandescent lamp. Still, we are in incandescent category only. This one is something different, but it is consuming a huge watts, sir. There is no doubt in it. Costly also. Those days, 30 years back, we were using halogen lamps. Nowadays, no one is using this, I think. We used to purchase halogen lamp in Yarabalacha district. Very few shops were having halogen lamps in those days. It has a tungsten filament only. Only thing, these lamps therefore generate a relatively large amount of heat. The use of halogen increases the efficiency and the extensive service life compared with traditional incandescent lamp. That's all. Nowadays, we are not using it.
In this case, the output will be instead of 10%, 20% like that, sir.
Yes, sir, yes,
output
sir.
may be increased. Yes.
Yes. Life is also increased. In those days, lighting was a costly affair, sir.
Yes.
When I was in school days, those were in primary, before primary school, I saw the main road will be having a line of mercury vapor lamps. It was
400 watts, 350 watts, 250 watts.
No, sir, more than 1,000, sir. More than 1,000.
Oh.
Yes. That came down to 250 when all those lamps were replaced with sodium vapor lamp. Yeah, in newsreels and all, I saw MGR inaugurating sodium vapor lamps in a particular road. The newsreel showed MGR inaugurated sodium vapor lamp in Walaja Road and all.
Yeah.
1/4 of that mercury vapor lamp. But the color rendering index and all, mercury was great, but sodium vapor lamp was very shabby.
They used to call it as sun lamp, sir.
Sun lamp.
The contrast will be better, of course, in the sodium vapor lamp.
What do you mean by the contrast, sir?
Contrast is it is almost daylight. We can see the objects with we can see with the help of with the sodium vapor lamp. Almost same color. If any color is it will not mean a mismatch, greenish or something reddish. It will not show like that.
So that means,
it will show as the color, a natural color, somewhat natural color.
You mean to say that is CRI, color rendering index?
Yeah, color rendering index. Yes, exactly. In that case, it is almost when you see the same object with the sun, how much the color rendering index will come, the same thing will come in with reference to this vapor lamp also. This is what
halogen lamp. Tungsten atoms are gets the breakaway from the tungsten element and again gets redeposited in a cooler region. It happens inside the bulb. These are all just want to have an idea, sir. Of
outdated one.
Outdated, no value for examination also.
Yes, sir.
Fluorescent lamp. The fluorescence principle, we know, sir. The tube contains small trace of gas such as mercury vapor. Mercury vapor is used for ordinary tube lights. Carbon dioxide for green, neon for red color. That's all. We use only mercury vapor. With a special fluorescent phosphorescent coating inside the incision surface. It contains two filaments, one at each end, the other one at the for end. When the starter opens, high voltage is induced, so that an conduction will take place, breaking the inert gas. This action provides a voltage across the electrodes that set off an electric gaseous mercury or discharge argon lamp, and this generates invisible UV radiation that is high enough to ionize the warmed up gas inside the tube. The ionized gas, also known as plasma, excites the fluorescence coating so that it gives a visible light. Even tube light has also become outdated now. Ballast is needed to start and operate fluorescent lamp. These are all standard terms of T12, T8, T5, T2. It refers to the diameters. 1.5 inches diameter is called T12. This is a normal size. T8 is smaller. The circuit diagram is, this is the ballast. We usually call it as choke. And the filament will go as a series circuit. The starter will close first and open, inducing a voltage. Then there will be a arc discharge from this end to this end. That's all. CFL is nothing but the same thing within a compact size. That's all. Sodium vapor lamp. In sodium vapor lamp, there were two types: are low pressure sodium vapor lamp and high pressure sodium vapor. Low pressure sodium vapor lamp is very the energy consumption was very low, sir. So in those days it was so economical one. High pressure sodium vapor lamp. The high pressure sodium vapor lamp is widely used for outdoor and industrial applications, as the light is yellowish. Its higher efficacy makes it better choice than metal halide for this application, especially when good color rendering is not a priority. Color rendering index is not a priority. When it is not a priority, we use HPSV lamps. HPSV lamps differ from mercury and metal halide lamps in that they do not contain starting electrodes. The ballast circuit includes a high voltage electronic starter. See the temperature, sir. The arc tube is made of ceramic material which can withstand temperature up to 1300 degrees centigrade. 1300 is the temperature inside a boiler. The energy flow diagram. This may be useful for examination point of view, sir. HPSC, unlike incandescent lamp, it gives out 30% energy as visible radiation. 60% lost by conduction convection. Only 10 or 20% is infrared radiation. See, 0.5 UV is there, sir.
Yeah. Noted, sir.
Mercury vapor lamp. In a mercury vapor lamp, the electromagnetic radiation is created from discharge within mercury vapor, but the regime is different than that is called normal fluorescent lamp. The high pressure mercury vapor will be inside the mercury vapor lamp. Lamp also includes argon, and the initial arc is struck in an organ. The energy from this discharge vaporizes the mercury to get the main discharge going. %, only visible radiation, sir. That's why the sodium vapor lamp were replacing the mercury vapor lamp.
Here the ultraviolet is more.
Yes, sir. Same thing. We are reading the history now.
Yeah.
Metal halide. Metal halide lamp. Or 25% visible radiation is there. Metal halide. When you find free time, you can read it, sir. The principle and all. You cannot remember also. That's the problem. Light emitting diode. Even for light emitting diode, the theory you can read it in the books or any books or even in Google, sir, you can see it. It's very much available. LED principle is very much available in YouTube and everything. So the advantages of LED. First one is low power consumption. Second one is directional light output. It gives out light in one direction only, sir. Not as a point source inside a sphere. In one direction only, it gives out heat. High efficiency, long life up to 1 lakh hour. No warm-up time is required. The other lamp fittings requires warm-up and some would have seen those say mercury lamp and sodium vapor lamp. It would be taking few seconds or even for 1 minute, I think. That warm-up time is required. It's not required for LED and all. High resistance switching cycles. High resistance switching cycles. Frequent switching and off doesn't change the inherent character of the LED lamp. High impact and vibration resistance. Yes. No UV or IR. Color control ability. Allows dimming. Mercury field. So all these things point to LED now. Induction lamp is another category, sir. Just have a knowledge about it. It gives out white light output. Uses magnetic field to excite gases inside the particular tube, fluorescent tube, and no arcing is given inside this lamp, sir. It is totally external. It consists of two main parts: ballast and sealed gas filter bulb. Light is produced via electromagnetic induction without an electrode or electric connection inside the bulb. Instead, high frequency electromagnetic fields are induced from outside the sealed chamber. The circular one is the tube, sir. Outside, we have two magnetic rings. It gives out visible light and ultraviolet radiation. The actual photo. Luminous performance characteristic by commonly used luminaries. Incandescent. See, sir. For CRI, it scores 100 marks. Excellent. But lifetime is limited to 1000 hours only. Lumens per watt is 8 to 18 lumens per watt. Fluorescent lamp, whereas the lumens per watt is 46 to 60. It's also good in color rendering index. Typical light is 5000, nearly 5 times that of an incandescent lamp. CFL almost same, sir. No difference. But I don't know why this one is high typical life, almost double that of regular fluorescent lamps. High pressure mercury vapor lamp, lumens per watt is almost similar. Color rendering index is not good, but fair. Life is 5000 hours only. Halogen lamp. See, halogen lamp is nothing but an incandescent lamp. That's why the first one and the fifth one have got score of 100 marks. Halogen lamp is nothing but an incandescent lamp. CRI is 100. Typical life hours is 2000 to 4000. High pressure sodium vapor lamp. Sodium vapor lamp has got very poor CRIs of 22 only. Whereas the life is more than 6000 And low pressure sodium vapor is the lowest CRA, sir. It has the lowest CRA. See, don't forget. Which one has got the highest CRA? That is incandescent lamp. Halogen lamp is also incandescent lamp. That's why it scores also 100. 100 CRA is nothing but a number, sir. No units or not. Whereas LPSV is very poor in CRA, that is 10%. The next one is, yes, sir.
Why they are written as SOX or more term?
Sorry,
Low pressure sodium.
Yes, sir.
They are written one
No,
more
sir.
term.
Low pressure
SOX.
LPSV, we have not seen it, sir. But even for we can see it has a black and white movie, sir. That's the problem.
No, the SOX they are written SOX.
SOX. Oh, LPSV SOX. I don't know why. SOX. Sorry. I don't know why they have written it. SOM. We'll check.
That is
check it
why
up.
I told you no previously. Low pressure lamp sometimes called, I mean, high pressure lamp sometimes called a sun lamp.
Oh, that is some SOM sun. Okay,
What about this SOX? It is different. Because in our industry we used to have high pressure sodium vapor lamp only. Now that also. Earlier it was there.
I don't know why they have written it as sun and the SOX. We'll see to it, sir.
Okay.
Metal halide lamps. Lumens per watt, everything is the incandescent lamp is the lowest, sir. Whereas low pressure sodium you see highest.
Yeah.
Even greater than LED lamps. The LED lamps have got color rendering index as very good, but scores 80 only. Induction lamps, very good color rendering index. Lumens per watt is almost same, 65 to 90. See the lives are extraordinary life for induction lamp, 60,000 hours to 1 lakh hours. Whereas LED lamps have lifetime for 30,000 to 60,000 only. So in this first part, this particular tabular column alone will be useful for us, sir. Oh, we have come to the end. What is time, sir? 10:30, yeah.
Yeah, 10:25.
Okay, sir. Okay. Okay, sir. The second part will be the design and all, and some theoretical part will be just points to share. As I told already, that will be built in the 11th day. I think one part is that that is HVAC. HVAC means heating, ventilation, and air conditioning. The appropriate person will be Dr.MGRERI. I think I'm not competent enough to deal that particular chapter. I asked her to prepare for that, and she will be presenting it for you. Okay, sir.
Okay.
I think with this, I completed 9 chapters, sir. I have not covered, but I have given a good introduction, I think. Well enough introduction, I think. We'll be again discussing the same chapters one by one, so that we'll be completing and we'll be directly going to the examination. That's all. Right, sir? With a little practice. Definitely with a practice. Without practice, we cannot go. And but the subject 2, we have got much of portions to complete, sir. For electrical, we have completed a major portion, and the mechanical portion we need to cover up within a short period. So we will see tomorrow what we can do, if possible. If no one is presenting, I'll be starting the chapter 1, 2, and everything as usual for revision, and we'll be closing that particular chapter for the examination. No further presentations will be there. Okay, sir.
Okay, okay.
What else, sir? Can we close now or discuss?
Okay, sir. Already